Hi everybody, today we're going to talk about using the normal distribution, and I'm going to show you steps in Desmos. In this video, we're looking at normal distributions that are not standard normal distributions, meaning our mean and standard deviation aren't 0 and 1. Because the mean and standard deviation are not 0 and 1, we just need to enter them into Desmos to let it know how to adjust the normal distribution to fit our data set. Let's start with a data set that is normally distributed with a mean of 14 and a standard deviation of 3.9. We'll find the probability that x is less than 16, greater than 7.4, and between 11 and 15.7. The first thing we do is we go to Desmos and we enter normal dist. Or remember, you can open the keyboard, go to the functions, go down to distributions. When you put in a parenthesis, we need to enter our mean, which was 14, put a comma, and then put in our standard deviation of 3.9. I'll click the magnifying glass to fit the data. This way I can see the mean of 14, and then the width is determined by the standard deviation of 3.9. The first thing we said we wanted to find was the probability that x is less than 16. So I'm going to hit find cumulative. And less than 16 says 16 is the max. Notice this is a little bit to the right of our mean of 14. Now I'm looking at all the data that is less than 16, which is 0.69596. I'd call that 0.696. Next, we're going to find the probability that x is greater than 7.4. Greater than says I want to put 7.4 as my min. I'll get rid of the maximum by deleting, and then I click away. I want you to notice that 7.4 is kind of far away from our mean of 14. Remember, our standard deviation is 4, so if we go down 4, that's 10. We go another 4, that's 6. So we could find the z-score, but I'm between -2 and -1 standard deviations away. What I'm looking for is everything greater than 7.4, which it says is 0.9547. So 95.47% chance that my value is greater than 7.4. Let's do one more with this distribution. We want to find the probability that x is between 11 and 15.7. So I put 11 as my min. I put 15.7 as my max. I have a shaded region that shows me the distribution, and it says that's 0.447666. Let's call that 0.4477. Next, let's try an application. We're given that the volume of an espresso is normally distributed with a mean of 0.85 ounces and a standard deviation of 0.8. We want to find the percent of espressos that are between 0.8 and 0.9 ounces. Then we're also going to find the percent of espressos that are over 1 ounce. So back in Desmos, I want to change my mean and my standard deviation. My mean was 0.85 ounces, put a comma, my standard deviation was 0.08. Click the zoom fit so that I have a new normal distribution. Let's click up top to see that my mean is 0.85. The first thing we want to find is the probability that our espresso is between 0.8 and 0.9 ounces. This means we want to go half an ounce lower and half an ounce higher than the mean. Desmos shows us that the probability that our espresso would be between 0.8 and 0.9 ounces is 0.4680. We also wanted to know the probability that the espresso was over an ounce. Over an ounce says the minimum would be 1, and we wouldn't have a maximum, which says it's 0.03039. We will call that 0.0304 or 3.04%. Notice that this is in the tail area of the graph and is a really small chance of occurring. Our next problem says, assume the weights of quarters are normally distributed with a mean of 5.67 grams and a standard deviation of 0.07 grams. If a vending machine will only accept quarters that weigh between 5.5 and 5.8 grams, let's find the percent that will be accepted and the percent that will be rejected. Let's adjust our mean and standard deviation in our normal distribution. We had a mean of 5.67 and a standard deviation of 0.07. We'll zoom fit our graph, and then we're looking for the probability that the coin is between 5.5 and 5.8. You can see that the coins that are 5.5 to 5.8 ounces account for most of our normal distribution. In fact, Desmos tells us that this is 0.960775, which I would call 0.9608. So 96.08% of coins would be accepted by the vending machine. To find the probability that the coin is rejected, we find 1 minus 0.9608, which is 0.0392. Our last application says the number of people that ride an amusement park roller coaster is normally distributed with an average of 1,200 passengers per hour and a standard deviation of 300. We're going to find the percent of the time there will be less than 800 rides per hour, the percent of time there will be more than 1,500 rides per hour, and the percent of time that there will be between 1,000 and 1,650 rides per hour. Let's adjust our mean and standard deviation to be 1,200 and 300. We'll change the zoom fit, and because we want to know less than 800, I'll make my maximum 800, and then remember to delete the minimum. So I want you to notice our mean at 1,200, our value of x being at 800, and it says 0.0912 is the probability that we'll have less than 800 riders per hour. Then we wanted to know the probability there were more than 1,500. More than 1,500 says set your min at 1,500, delete the maximum. Now we're on the right side of the graph. Again, the mean at 1,200, our x value 1,500, greater than 1,500 is shaded to the right, and we see the probability is 0.15865. I'm going to call that 0.1587. Lastly, we want the probability that there's between 1,000 and 1,650 riders. So we have a minimum of 1,000, a maximum of 1,650, which gives us a probability of 0.6807. This shows us there's a 68.07% chance that on any particular hour that we have between 1,000 and 1,650 riders. As you're working with Desmos, remember to always adjust your mean and your standard deviation and change the zoom fit so you can see the area that you're finding and the distribution.